When you toss something in the trash, you probably don't give it a second thought, right? It just disappears into a truck, and that's kind of the end of the story. But behind that simple act is this massive, incredibly complex, and often wildly expensive logistical puzzle. Today, we're diving into a fascinating case where researchers used some powerful math to solve a multi-million-dollar trash problem, and in the process, they transformed total chaos into a model of efficiency. It's such a simple question, but the answer? Well, it's anything but. For most of us, our trash just goes away. But as we're about to see, away can be a sprawling, super inefficient network that costs an absolute fortune.
So let's zoom in on Brazil, specifically the state of Parana. For the nearly 11.5 million people living there, the journey their trash takes is a perfect example of this messy complexity. Their system for managing all that waste wasn't just inefficient. It was costing taxpayers a ton of money.
Okay, so let's really dig into Parana's trash problem, because before you can fix something, you gotta understand just how broken it is. And wow, this system, it was a special kind of broken. The first thing they found was just chaos. I mean, picture trying to coordinate 399 different towns and cities. The whole state was carved up into 174 different waste agreements. But these weren't neat little zones. Oh no, they were all over the place, geographically scattered. A truck from one town might have to drive right through another town's zone just to get to its own landfill. It made no sense. But here's the real kicker. Even with 174 different agreements, the system still didn't cover everyone. A staggering 64 municipalities were just left out, completely unserved. All their waste, we're talking about 850 tons a day, had no proper place to go. It often just ended up in open garbage dumps, which is a huge environmental and public health nightmare. So when you put it all together, the system was just failing on every single level. 16% of towns had no service at all. Waste was being hauled for insane distances. In one case, nearly 400 kilometers. Some trash was even getting trucked all the way to a neighboring state. All this inefficiency, the scattered zones, the long-haul trips, it all meant more fuel, more pollution, and just massive unnecessary costs. So, faced with this absolute tangled mess, what do? Well, these researchers decided to fight waste with one of the most powerful tools we have for optimization, math. They were convinced they could design a much, much better system from the ground up. They turned to a classic idea from logistics called the facility location problem. Now that sounds complicated, but stick with me. It's basically the pizza delivery puzzle, right? If you're opening a pizza chain, where do you put your restaurants so that everyone in the city gets their pizza hot and fast without needing a million delivery drivers? That's it. You just swap pizzerias for landfills and customers for towns. So they asked this really bold question. Could we use this exact mathematical approach to design a totally new, perfectly optimized landfill network that serves every single one of Paraná's 399 municipalities while cutting down on both transport and construction costs? So how'd they actually do it? How do you go from this cool idea to a real concrete plan? Well, their method was a surprisingly elegant 5-step process. They followed a super clear 5-stage game plan. First, they gathered all the data, where the cities are, how much trash they make. Second, they found the true geographic center of each town. Third, they calculated all the distances between them. Fourth, they fed all that data into their math model and let the computer do the heavy lifting. And finally, step 5, they looked at what the model spit out to see if the new designs were actually any better. And this right here, this is the secret sauce. This is the clever bit. Instead of using a town's political center, like where its city hall is, they calculated its geographic centroid, its true center of gravity. So why is that such a big deal? Well, because when you do that, the model automatically creates these perfectly neat, geographically connected waste zones. You don't need any extra complicated rules. It's a simple switch that makes the entire puzzle way, way easier to solve. Now, after all that number crunching, the model didn't just give them one single answer. Nope. It gave policymakers 2 distinct paths forward, basically 2 possible futures for how Paraná could manage its waste. So path number 1 was what they called the ideal world scenario. This is the fun one. It's like, what if we had a magic wand and could just wipe the slate clean? Forget the 174 messy agreements that exist now. What would the absolute best system look like if we built it from scratch? And the results? Whoa. Just
Wow. The ideal system would only need 59 landfills, down from 174. Daily transport costs slashed by almost half, a 49% drop. And get this, because bigger landfills are actually more cost-effective to build, the total construction cost would also go down by about 4.4%. Better service for less money. It's a total win-win.
Yeah, that's fantastic. But let's be real. In the real world, you can't just ignore all the infrastructure you already have. So what if starting completely over just isn't an option?
And that brings us to the second, much more practical simulation, the realistic upgrade. The goal here was, okay, let's work with the 171 landfills we already have in the state. How can we reorganize everything and add new facilities only where we absolutely have to make sure everyone is covered? So the model's first recommendation was to build 25 new strategically placed landfills. This was the key to finally getting those 64 forgotten towns covered and making all the service areas much more compact and efficient. Now, I know what you're thinking. Wait, add 25 landfills? Isn't that going to cost more? But here is the absolute jaw-dropper. By just redrawing the map and optimizing all the routes, this realistic plan would slash daily transportation costs by, wait for it, 80.2%. That is not a typo. The savings on fuel, treks, and time would be absolutely astronomical.
So what does all this mean? Well, this research is way more than just a garbage plan for one state in Brazil. It's a powerful blueprint for how cities and regions anywhere in the world can rethink these huge, complex public systems.
And you can really see it. The result is just what the quote says, a transformation from pure chaos to order. You look at the before map, and it's this confusing, jumbled mess of overlapping zones. The aftermaps for both scenarios, they're clean, they're logical, and every single town is neatly assigned to its closest landfill. But the most compelling story is in the final numbers. When you project the total cost over a 20-year landfill lifespan, the results are staggering. The current broken system is on track to cost about $395 million. The ideal scenario? That drops it to $250 million. But look at the realistic scenario. Even with the cost of building 25 new landfills, the transport savings are so immense that its total cost is just $171 million. The most practical, implementable solution is also the cheapest by far, saving over $220 million. That's insane.
And that's the ultimate takeaway here. This kind of data-driven optimization isn't just for managing waste. It's a blueprint you could use to improve hospital networks, to draw up better school districts, to make emergency services and public transit more efficient. It's all about using logic to make public money go further and serve citizens better. So it leaves you with this powerful question. If a smart, mathematical model can untangle a problem this complex and save hundreds of millions of dollars in the process, what other stubborn, expensive city challenges are just sitting there waiting for the right algorithm to solve them?